You all right?
Yeah.
Let's talk about the Pythagorean Theorem. So you guys already told me a lot of good stuff about this. You threw out the formula, the a squared plus b squared equals c squared. And you know that this relates to the sides of what kind of triangle?
Right triangle.
Relates to the sides of not just any triangle, but you're right, a right triangle. Where do A, B, and C go in this triangle?
The C is the long one. The one that
The C is the longest one.
Yeah.
A and B are the short ones, the ones that make up the right angle, right? What do we say that C is? C is the hypotenuse. And what about A and B? They're legs. See, right triangles have legs. They know how to use them. Now, the hypotenuse, as Octavia already mentioned, it's always going to be the longest side, right? And you can always identify this because it is always the side that is opposite what? It's always opposite the right angle. Okay. So this is your Pythagorean theorem. So if I gave you just an example of what this guy looks like. If I have the hypotenuse as 15, have one of the legs as 12, and I have the other leg as some unknown value, and we'll call it x for the sake of argument. How would you figure out what x is? You what?
Subtract that. Square and subtract the leg in the bottom.
According to the Pythagorean theorem, I would have side squared plus side squared equals what? Hypotenuse squared. Or leg squared plus leg squared is hypotenuse squared. That's what it says. So this is an equation that we should be able to solve. So we have x squared plus what?
144.
Remember, you guys made your list of squares and cubes, so it should be easy to identify these. What's 15 squared?
225.
You know, it's just 225. You don't need to stretch out the last syllable. Right there. So now I got to get x squared by itself. So I'm going to subtract 144. Just like old times. I like this stuff. So what does x squared equal?
121.
It equals 81.
Oh. I don't know how to go.
I don't either.
Oh, yeah.
So now remember, x is supposed to be a positive number because we're talking about the length of the side of a triangle. So what does x equal here? X equals 9. What do you guys think about that? Is everybody happy? I know I'm happy. Just look at my face. Huh?
That's a little refresher.
Well, I know you guys saw this in 0306, right?
Mm-hmm.
Did you guys also talk about Pythagorean triples? But this, it's not a person.
Force it.
Pythagorean triples. These guys are integer solutions to the theorem. These are integer solutions to the theorem a squared plus b squared equals c squared. Now there are an infinite number of Pythagorean triples, but there are some that we see so often that we have these guys kind of memorized. So common Pythagorean triples would be, the most common one is 3, 4, 5. Okay? 3, 4, 5, because if you do 3 squared plus 4 squared, what do you get? You get 5 squared. Now see, I really like this one because if you have one of those old standard definition TVs, the aspect ratio of one of the old TVs is 4 to 3. Do you know what it is for widescreen? 16 to 9. Most widescreen is 16 to 9. Okay. But the reason I like it this way is because, well, the diagonal, since it makes a right angle, has a length of 5. So an old standard definition TV, if you told me that it was 40 inches, I could tell you what the dimensions are the rest of the way, because it was based off of a 3, 4, 5 right triangle. Other common triples would be 5, 12, 13. You see this guy a lot. 7. 7, 24, 25. 8, 15, 17. 9, 40, 41. These are the most common Pythagorean triples you're going to run across. And the cool thing is, it doesn't have to be these exact triples. You could have a multiple of this. So, if I told you, going back to that TV example, here's my TV. If I said that the aspect ratio is 3 to 4, or as they would say 4 to 3, like that, if I say this is 40 inches, how much bigger, by what factor, is this guy from the 3, 4, 5? It's bigger by a factor of what? 8. Which means the height of the TV should be what? Not 3, but 3 times 8, which is 24, and the base was 4. So if I'm multiplying it times a factor of 8, the base would be 32 inches. And what you would find out is that if you did 24 squared plus 32 squared, you would get 40 squared. You can take any of these triples over here, or any triple that exists. If you multiply or divide everything by the same number, it's itself going to be a triple. For example, if I were to take these guys right here, multiply them all by a factor of 2, well, then the triple of 10, 24, 26 would also work. Okay? As long as the sides are in this particular ratio, 5 to 12 to 13. So if the sides are a ratio of 10 to 24 to 26, these guys all have a common factor of what? 2, and so it reduces to that ratio of 5, 12, 13. Well, look at the last example that I did up here. I said this guy was equal to 9, so the ratio is 9 to 12 to 15. What's the common factor for 9, 12, and 15?
3.
If you reduce all those by 3, what do you get? 3 to 4 to 5. So you see that it matches up with that 3, 4, 5 ratio. I could also take something like this guy right here. If I multiplied everything times an 8, basically you divide by 8, then by having 7 over 8, 24 divided by 8, which is 3, and 25 divided by 8, this right here would be a triple. It's not a very pretty triple, but it is something that would work out in the Pythagorean theorem, because I scaled everything by the same factor. Okay? So these are just some numbers I want you to be familiar with, to look out for them, because you see them a lot when you're dealing with right triangles.